Hi class, we continue our study in chapter 14 by moving into section 14.4. And this section is called tangent planes and linear approximations. We're going to focus just on two concepts in this section, the concept of tangent planes, and then we'll learn about differentials as it relates to functions of more than a single variable. So this lecture here is going to focus on tangent planes. All right, so what exactly is a tangent plane? The tangent plane is some surface S. So this blue kind of shape here is the surface we have, and this brown shape is the tangent plane that we're looking to find. So the tangent plane is some surface F at some point P is defined as the plane that contains both the tangent lines T1 and T2. And we've talked about these tangent lines T1 and T2 in the previous section. Okay, so how are we going to find the equation of this brown tangent line, or this tangent plane, to a surface at just a point? Okay, so this plane just touches this surface at this point, but remember that this brown plane extends in all directions infinitely, but just touches there, just tangentially at that one point. All right, well, it's actually really easy to do it. There's a formula for doing this. And it just goes the following. Suppose f has continuous partial derivatives. An equation of the tangent plane to the surface z is a function of xy at the point x sub 0, y sub 0, z sub 0 is just the following. Z minus z sub 0 is equal to the partial derivative of f with respect to x evaluated at the values x0, y0 times x minus x0 plus the partial derivative of f with respect to y evaluated at x0, y0 times y minus y0. All you really need to do is find the partial derivatives here and then just follow the equation. All right, so let's just do an example here. So let's find the tangent plane to this shape here defined by z is equal to 2x squared plus y squared at this specific point, 1, 1, 3. Okay, looking back at the formula, we're going to need the partial derivatives. So the partial derivative of this function with respect to x ends up just being 4x. The partial derivative of this function with respect to y just ends up being 2y. Okay. Then plugging in the values of x0, y0, which would be 1, 1, we get 4 and 2. This just gives, okay, z minus z0, z sub 0. So this is z minus 3 is equal to the partial derivative evaluated at x0, y0, which is 4, times x minus x0, which is 1, plus the partial derivative of y evaluated at x0, y0, which is 2, times y minus y0. And then you can just distribute here and then add this 3 over, and this ends up being the equation of the tangent plane right here. So again, just real briefly following the formula and finding the partial derivatives will give you the equation of the tangent plane.